Okay, it's really hurting my heart. I only have 3 more episodes of Math Gains, Math Muscle style coming here. But we're going to start our last chapter. This is PSC 3, Lesson 1. We're going to identify and create some translations, rotations, reflections, all sorts of good stuff. A translation, just so you know, is a fancy word for you take an object and you just shift it. That's a translation. So here's a horizontal translation. Here's a vertical translation. Now, could a vertical translation go down? Yeah, vertical down. Or left for horizontal. What if I did both? Oh, diagonal translation. That's a shift left and up or down and right. Oh, fancy. That's a translation. A reflection, a rotation would be something to this effect. All right, if I took this object and I rotated it. Now the axis of rotation in this case would be the point that doesn't change location, or where I'm basically sticking, say a peg into this object. I'd say this is about the axis of rotation, right about there. Let's check it out. Oh gosh, come on. No, don't do that. What the heck? Yeah, there's the axis of rotation. Isn't that cool? What if I took, and I made the axis of rotation like down here? Wouldn't that put, if I did a 90-degree rotation, wouldn't that put that heart right about here? So that's the axis of rotation there. All right, and then reflections. Reflections are cool too. Let's take this object here. This little person winking. Right? If I reflected that over this line, yeah, it just flips it right over that line, right? It takes this point, that eye, and that winking eye, and does that to it, yeah? Or if I did a vertical reflection, I'm almost doing the entire lesson right now, which will make it easier later, but I get this. Yeah. Oh, and this is really cool. Let me reflect it one more time. If I reflected this vertically right here, it would end up down here. And look at that. That's actually the horizontal reflection of that one. Oh. So if I reflected here, then here, that's going to give me the same image as if I reflected here, then there. Cool. Okay, so let's talk some details. All these words above I don't really care about, so you can read them on your own time. This is the transformation machine. You take an object, which we call the pre-image, what you start with. Pre, start, before, etc. And then you do some sort of transformation to it in here. This is just a visual representation of you're doing something to that object. You're either rotating it, reflecting it, or translating it. And then out pops this image, right? In a new location, maybe not in a new location. What if I flipped a symmetrical object? I did a reflection about that axis. Would it look any different? No, it would reflect on itself. Oh, so the image may not look any different than the pre-image, but most of the time it does. Let's keep going. All right, so the different types of transformations. The first one is called a translation. So here's Hans. Hi. Hans is really good at airwalking. Hi. The image of Hans. Very good. Thanks, Hans. That was impressive. Nice work. When performing a translation, we translate a certain distance. If one point is translated 5 centimeters, then every single point is translated 5 centimeters. We can also define translations using a translation vector. Ew, vectors. That sounds like physics. Anybody in physics? Yet? No? Okay. So here's an example of a translation vector. What do you think that the 6 is going to do to all of the x's? All right. It's going to move our x's which direction 6 units? X is left and right. So a positive number would tell me that x's are going to go which direction? To the right 6 units. So I'm going to take each of these. I'm going to take this -4 and I'm going to move it over to a +2. Okay, and then I'm going to take this 0 right here and I'm going to shift it over to 6. And I'm going to take this -2 here and I'm going to shift it over to 4. I'm adding 6 to each of those. All right, so there's our, we're not done because our vector is not complete. But now what are we going to do to the y's? Move it which direction? Up or down? Up 5, right? So I have this 2. I'm going to move it up to a 7. I have this -3. I'm going to move it up to a +2. I have this, what was this, a -3 again. I'm going to move that up to a +2. And then I have this image. And it's not perfect, but look at that. This object has been shifted over. Oh gosh, that was, yeah, that's why. Okay. Got it. Uh-oh. Go back. There we go. All right, so I had the wrong point there. Got it. Okay, so I take this point right here, and I go up to 2. There it is. That looks a lot better. So I've shifted this triangle over, and then I shift that triangle up. Ooh, yeah. That looks a lot better. These lines here got messed up. That's what I wanted. Cool. That's a translation. What would this translation vector do to the object? Which direction would that shift our object, whatever it might be? Left 3, up 2, right? Left 3, up 2. What would this vector do to it? Left 5, up how many? 0, right? It'd just be a shift horizontally to the left. Cool. Another way you might see this demonstrated is it might say this. All right, that would be all of the x's to the left 5, all the y's up 3. All right, that's another notation you might see. Cool. Our next transformation is called a rotation. I think it's pretty clear that Hans here either fell off the shed, although that would be impressive to be able to rotate like that, falling off the shed. That's impressive. But here is where I would put that center of rotation. Yeah, I think we can agree that as Hans rotates, this foot would travel in this circular motion. This foot would travel in this circular motion. And you can see that the center of rotation would be such. Cool. Here's another example of how to look at a rotation. All right, so if we do a clockwise rotation, Hans, did you rotate? Yeah. Why were you rotating? Ah. That's not an answer, Hans. Oh. Did you jump off your shed? No. Okay. The angle of rotation will be this angle here. That looks like an angle, I don't know, about 60 degrees. Does that look about right? Less than 90. That's an angle of rotation of about 60 degrees. If a figure can be rotated about a point in such a way that its rotated image coincides with the original figure, I'm going to explain in words in a moment, then the figure has rotational symmetry. Example being like a flower like this, right? Let's see if I can do this. Oh yeah, here we go. So let's take this flower and let's place it on the other one. Okay, they're the exact same image, and I'm going to rotate it. All right, so let's mark part of this. Not marky mark, but mark. Okay, let's mark part of it so we know where it's at. Right, and let's group this. All right, so I'm going to rotate this. I want to know how many times it's going to coincide with itself. I think you have a guess. I'm sure you do. Anybody have a guess out there? How many times? 5, yeah, that's pretty good. All right, so we started there at 0. Oh, there's 1, 2, 3. Uh-oh. 4 and 5. So the degree of rotational symmetry would be 5. Cool. Some think of the degree of rotational symmetry as how many degrees it takes to get to an image that looks exactly like the pre-image. How far would this be? That would be 360 degrees divided by 5. Oh, I don't know what that is. 30 divided by 60, 60, 72? I think that's 72 degree rotational symmetry. So these two kind of coincide together, right? This 5 and this 72. Let's keep rolling. Okay, our next is called the reflection. There's Hans again and his brother Franz. Anybody? Saturday Night Live skit? Hans and Franz? No. Okay. Okay, so we got a pre-image, we got an image, and then we got this line of reflection. Do you know what's true about this segment from here to here? And this segment from here to here? What's true about the green point? What does it do to that blue segment? Cuts it in half and forms what angle? 90. Does the same down here. Forms a 90. So as we fill in some information below, I think it might be on the next slide. So we'll wait until then. But it's actually pretty cool. It brings back this idea of the perpendicular bisector. Okay, so here it says what happens when part of our pre-image is on the line of reflection. That same part of the pre-image stays on the line of reflection. Oh, groundbreaking. I'm going to go sell everything and put stock in transformations. Franz did that. Now he's very wealthy. He has a protein powder shed in his backyard. Okay, so let's further investigate this idea of reflections. Oh my gosh, this is when it gets good. Could you take this pre-image? I can't wait. This is going to be great. And could you draw the image if it's reflected over this line? This is going to be amazing. I love how awesome you guys are at drawing. Would you try it? Just give it a try. I want to see. Draw that hexagon on the other side of this line in a way that looks like it might be a perfect reflection over the blue line. Okay, here are the mechanics of drawing a reflection. Okay, I'm going to do my best here. It won't be perfect. I'm going to draw a line perpendicular from that vertex, and then I'm going to draw another perpendicular line about that same length. I'm going to do the same thing for this side. You're like, oh, those are the same. No, they're not. That one's a little bit shorter. I'm going to do the same thing here. A little bit longer. There we go. Okay, so then I'm going to connect these. A decent start, right? I have to make 6 perpendicular bisectors. I know, you're excited, aren't you? Should I freehand the rest? See if I can screw this up? Yeah? Okay. Jean. Jean. Thanks, Franz. Terrible. The first half was good. The second half was bad. It's just, it's hard to do that. Unless, you know, you got a nice. So I'd say that's average to below average. But the line of reflection is the, what do we call it? Perpendicular bisector. It's the perpendicular bisector of every segment joining a point in the original figure with its image. This original figure, just so we get used to the wording, is called the pre-image. Pre-image. Excellent. Let's talk a little bit about reflectional symmetry. An object has reflectional symmetry if I can draw a line through the object that cuts it directly in half. How many times could I do that to that object? How many? Here's two, right? How many other ways can I do it? How about this? 3? Oh, poor. There we go. Okay, so this object has degree 4. Reflectional symmetry. Reflectional symmetry. All right, and that's it. Thanks for your help, Hans, even though you didn't help at all. And Franz, I'll be consulting you later if I run out of protein powder. No problem. Thanks. Free tutoring for your children any day. Like, subscribe. $19.85 to GNC or to the Franz Protein Shed. Out.